How does titration work with acids and bases? Imagine trying to find out how strong a mystery liquid is without tasting it directly. That's what titration helps chemists do with acids and bases. It's a way to measure how much of one solution is needed to neutralize another. This process is like a careful balancing act, where the goal is to reach a point called the equivalence point. At this moment, the acid and base have completely reacted with each other. The process starts with a solution of unknown strength called the analyte. You put this in a flask and add a few drops of an indicator. Indicators are special chemicals that change color when the reaction is just about finished. Then, a solution of known strength, called the titrant, is slowly added from a device called a burette. The titrant is the opposite of the analyte. If the analyte is an acid, the titrant is a base, and vice versa. As you add the titrant, it reacts with the analyte in a process called neutralization. This reaction produces water and a salt, which is a different compound. You carefully measure how much titrant you add. When the indicator changes color, it signals that the reaction has reached the equivalence point. This means the number of moles of acid equals the number of moles of base, so they have canceled each other out. Knowing the volume and concentration of the titrant used, you can calculate the unknown concentration of the analyte. This is done using simple math based on the balanced chemical equation for the reaction. During titration, the pH of the solution changes. For strong acids and strong bases, the pH at the equivalence point is about 7, which is neutral. But if you are working with weak acids or weak bases, the pH at the equivalence point shifts away from 7 because of their different properties. That's why the choice of indicator depends on the type of titration you are doing. Titration is used in many real-life situations. It helps test water quality, measure acidity in food products like vinegar, and analyze blood pH or drug concentrations in medical labs. It's a precise way to figure out how much of a substance is present without tasting or directly testing the unknown solution. By slowly adding a known solution and watching for a color change, scientists can determine the strength of an unknown acid or base with accuracy.